Electrical engineering is a field of engineering that generally deals with the study and application of electricity, electronics, and electromagnetism. This field first became an identifiable occupation in the latter half of the 19th century after commercialization of the electric telegraph, the telephone, and electric power distribution and use. Subsequently, broadcasting and recording media made electronics part of daily life. The invention of the transistor, and later the integrated circuit, brought down the cost of electronics to the point they can be used in almost any household object. Electrical engineering has now subdivided into a wide range of subfields including electronics, digital computers, power engineering, telecommunications, control systems, radio frequency engineering, signal processing, instrumentation, and microelectronics. The subject of electronic engineering is often treated as its own subfield, but it intersects with all the other subfields, including the power electronics of power engineering. Electrical engineers typically hold the degree in electrical engineering or electronic engineering. Practicing engineers may have professional certification and be members of a professional body. Such bodies include the Institute of Electrical and Electronics Engineers and the Institution of Engineering and Technology. Electrical engineers work in a very wide range of industries and the skills required are likewise variable. These range from basic circuit theory to the management skills required of a project manager. The tools and equipment that an individual engineer may need are similarly variable, ranging from a simple voltmeter to a top-end analyzer to sophisticated design and manufacturing software. History. Electricity has been a subject of scientific interest since at least the early 17th century. The first electrical engineer was probably William Gilbert, who designed the versorium, a device that detected the presence of statically charged objects. He was also the first to draw a clear distinction between magnetism and static electricity and is credited with establishing the term electricity. Then in 1762 Swedish professor Johann Carl Wilcke invented, and in 1775 Alessandro Volta improved, a device that produced a static electric charge. And by 1800 Volta had developed the voltaic pile, a forerunner of the electric battery. 19th century and 19th century, research into the subject started to intensify. Notable developments in this century include the work of Georg Ohm, who in 1827 quantified the relationship between the electric current and potential difference in a conductor, of Michael Faraday, the discoverer of electromagnetic induction in 1831, and of James Clerk Maxwell, who in 1873 published a unified theory of electricity and magnetism in his treatise Electricity and Magnetism. Beginning in the 1830s, efforts were made to apply electricity to practical use in the telegraph. By the end of the 19th century, the world had been forever changed by the rapid communication made possible by the engineering development of landlines, submarine cables, and, from about 1890, wireless telegraphy. Practical applications and advances in such fields created an increasing need for standardized units of measure. They led to the international standardization of the units volt, ampere, coulomb, ohm, farad, and henry. This was achieved at an international conference in Chicago in 1893. The publication of these standards formed the basis of future advances in standardization in various industries, and in many countries the definitions were immediately recognized in relevant legislation. During these years, the study of electricity was largely considered to be a subfield of physics. That's because early electrical technology was electromechanical in nature. The Technische Universität Darmstadt founded world's first department of electrical engineering in 1882. The first electrical engineering degree program was started at Massachusetts Institute of Technology in the physics department under Professor Charles Cross. though it was Cornell University to produce the world's first electrical engineering graduates in 1885. The first course in electrical engineering was taught in 1883 in Cornell's Sibley College of Mechanical Engineering and Mechanic Arts. It was not until about 1885 that Cornell President Andrew Dickson White established the first Department of Electrical Engineering in the United States. In the same year, University College London founded the first chair of electrical engineering in Great Britain. Professor Mendel P. Weinbach at University of Missouri soon followed suit by establishing the Electrical Engineering Department in 1886. Thomas Edison, Electric Light and Power Supply Networks. Karoly Zipanowski, Otto Blathy, Mixer Diacuta, the ZDB Transformer. William Stanley, Jr., Transformers. Galileo Ferrari's Electrical Theory, Induction Motor. Nikola Tesla, Practical Polyphase and Induction Motor Designs. Mikhail Olivo-Dobrofolsky developed standard three-phase systems. Charles Proteus Steinmetz, AC Mathematical Theories for Engineers. Oliver Heaviside, developed theoretical models for electric circuits. During these decades, use of electrical engineering increased dramatically. In 1882, Thomas Edison switched on the world's first large-scale electric power network that provided 110 volts direct current to 59 customers on Manhattan Island in New York City. In 1884, Sir Charles Parsons invented the steam turbine, allowing for more efficient electric power generation. Alternating current, with its ability to transmit power more efficiently over long distances via the use of transformers, developed rapidly in the 1880s and 1890s with transformer designs by Karoly Zipanowski, Otto Blathy and Mixer Diacuta, Lucien Gaulard, John Dixon Gibbs and William Stanley, Jr. Practical AC motor designs including induction motors were independently invented by Galileo Ferraris and Nikola Tesla and further developed into a practical three-phase form by Mikhail Olivo-Dobrofolsky and Charles Eugene Lancelot Brown. Charles Steinmetz and Oliver Heaviside contributed to the theoretical basis of alternating current engineering. The spread in the use of AC set off in the United States what has been called the War of Currents between a George Westinghouse-backed AC system and a Thomas Edison-backed DC power system, with AC being adopted as the overall standard. More modern developments during the development of radio. Many scientists and inventors contributed to radio technology and electronics. The mathematical work of James Clerk Maxwell during the 1850s had shown the relationship of different forms of electromagnetic radiation, including possibility of invisible airborne waves. In his classic physics experiments of 1888, Heinrich Hertz proved Maxwell's theory by transmitting radio waves with a spark gap transmitter, and detected them by using simple electrical devices. Other physicists experimented with these new waves and in the process developed devices for transmitting and detecting them. In 1895, Guglielmo Marconi began work on a way to adapt the known methods of transmitting and detecting these Hertzian waves into a purpose-built commercial wireless telegraphic system. Early on, he sent wireless signals over a distance of 1.5 miles. In December 1901, he sent wireless waves that were not affected by the curvature of the Earth. Marconi later transmitted the wireless signals across the Atlantic between Poldhu, Cornwall, and St. John's, Newfoundland, a distance of 2,100 miles. In 1897, Carl Ferdinand Brown introduced the cathode ray tube as part of an oscilloscope, a crucial enabling technology for electronic television. John Fleming invented the first radio tube, the diode, in 1904. 2 years later, Robert von Lieben and Lee de Forest independently developed the amplifier tube, called the triode. In 1920, Albert Hull developed the magnetron, which would eventually lead to the development of the microwave oven in 1946 by Percy Spencer. In 1934, the British military began to make strides toward radar under the direction of Dr. Wimperis, culminating in the operation of the first radar station at Bawdsey in August 1936. In 1941, Konrad Zuse presented the Z3, the world's first fully functional and programmable computer using electromechanical parts. In 1943, Tommy Flowers designed and built the Colossus, the world's first fully functional, electronic, digital and programmable computer. In 1946, the ENIAC of John Priest per Eckert and John Mauchly followed, beginning the computing era. The arithmetic performance of these machines allowed engineers to develop completely new technologies and achieve new objectives, including the Apollo program, which culminated in landing astronauts on the Moon. Solid-state transistors. The invention of the transistor in late 1947 by William B. Shockley, John Bardeen, and Walter Brattain of the Bell Telephone Laboratories opened the door for more compact devices and led to the development of the integrated circuit. In 1958 by Jack Kilby and independently in 1959 by Robert Noyce. Starting in 1968, Ted Hoff and a team at the Intel Corporation invented the first commercial microprocessor, which foreshadowed the personal computer. The Intel 4004 was a 4-bit processor released in 1971, but in 1973 the Intel 8080, an 8-bit processor, made the first personal computer, the Altair 8800, possible.